Lesson 11.5, finding distance using derivatives or a graph. Number 1 is a graph first. The visual might help you on the equation next on number 2. Particles moving along the x-axis so that a time of 0 to 18 is given by x of t, shown in the figure below. Find the total distance traveled by the particle on the interval from 0 to 18. So I made this little t-chart. It's definitely not needed on this type of problem, but the second one I'll be doing it again, so I thought it might help. We want some critical values, and critical values are going to be where our mins and maxes are, where our velocity is 0 because we're changing directions. So first of all, I want to start when our time is 0, since that's an endpoint of our domain. Then I'm going to do 3. Then I'm going to do 5. And then I'm going to do 8, not 8, sorry, that's a 0, but I want a 0 slope 10, 14, and then our endpoint 18. Okay, x of t is just the position. So at a time of 0, it's at a position of 6, just the y value there. At 3, it's a position of 0. At 5, it's a position of 5. At 10, it's negative 4. At 14, it's 0. And then at 18, it's negative 5. So distance then is literally just figuring out what's the difference. So if I go from 6 to 0, that is a distance of 6. It doesn't matter that I'm subtracting. That's the distance I'm going. I'm just going to the left. Okay, then I've got from 0 to 5, that's a difference of 5. 5 to negative 4, think of that on a number line. You got 5, you got negative 4, you're going to go back 5 and then back 4 more, so that's a total distance of 9. And then negative 4 to 0 is a distance of 4, and 0 to negative 5 is a distance of 5. You add all those up, and you get 6 plus 5 is 11, plus 9 is 29. That's our total distance. So again, on a graph, you could just count. Think 6 to 0, that's 6. 0 to 5 is 5. 5 to 0 is another 5. Wait, hold on. Yeah, you could go here. And then you could go from this 0 to this negative 4 is still an absolute value of 4. From negative 4 to 0 is another absolute value of 4. And then from 0 to negative 5 is an absolute value of 5, and then add all those numbers up, which gets 5, 10, 15, 25, 29. So up to you. But let's look at number 2. A particle moves along the x-axis so that at time t is greater than or equal to 0, its position is given by this function. Determine the total distance traveled by the particle from 0 to 5. So at least we don't have to go for a big x or t interval. We want to first find where is the velocity going to be changing. So that is finding the zeros or the critical values of our velocity function. So I would take the derivative first, set it equal to a velocity of 0. I'm going to factor out a 3. And then I'm going to factor further. This would be a negative 4 and a negative 2, which gets me a time of 4 and a time of 2, which do both fall in my domain. So I'm going to make a sign chart here going from 0 to 5. Put 2 and 4 in there. And then I'm going to be figuring out what my velocity is doing in each interval. So I would want to do, I could even start this way, start with a 1. 1 minus 4 is negative 3, so it'd be a negative. 1 minus 2 is negative, so negative times negative is positive. At 2, it should cross, and at 4, it should cross. So that tells me that my velocity is going to be a positive, a negative, and a positive. But now what I want to do is make a table to where I've got my time again, and I've got my x of t, and then I've got my distance traveled. So I'd want to use these critical values, including my endpoints. I'm going to do my 0, my 2, my 4, and my 5. And then you're literally going to plug those x values in to the original function. So that would be 0, 0, 0, that would be 20. And then I want to plug in 2 for the time. So it'd be 2 cubed minus 9 times 2 plus 24 times 2 plus 20. I get 58. So keep going for the 4 and the 5 and see what distances you get, or what positions you get. I realized I'd made a mistake. I should not have gotten 58. I should have gotten 40. I kind of marked over my t-squared there. So hopefully those are the right numbers. This matches what I said the slopes would be doing. 20 to 40 is increasing, and then it decreases. 40 to 36, and then it increases. You don't have to do this part. I just thought maybe it would help make the connection. So the distance traveled 20 to 40 is 20 units. 40 to 36 is going down 4 units. But again, we just want the absolute value of that. And then 36 to 40 is going up 4 units. So adding that would be 28 total.